Pulse Electronics, inside 5G. 5G. We've all heard of it, but what is it? Is it already here? And what will it do? By definition, 5G is the fifth generation of mobile networks. The first mobile network, 1G, launched way back in 1983, and since then, the uses and complexity have grown exponentially. These mobile networks can be divided into two realms: the supply side infrastructure and the demand side devices. The supply side infrastructure consists of the centralized servers, cell towers, base stations, fiber, edge servers, and small cells, and all the supporting software that enables the communication. The demand side devices consist of all the things that will consume and create the data: the cell phones and tablets, autonomous vehicles, transportation infrastructure, machines, security systems, smart utilities, smart homes, smart cities, and smart farms. The rollout of 5G has already begun, but full-scale adoption will take years. It is estimated that by 2025, half of mobile connections will already be 5G. Pulse Electronics is inside 5G. Our networking components and SFP cages facilitate communications across copper and fiber. Our wireless antenna components enable through-air communications, and our power magnetics components ensure that the system runs efficiently. But what is really driving the need for a better fifth-generation network? Today, humans, through their devices, either talk to other humans or request services from computers. And although our needs will continue to grow, this is not the real driver for 5G. The exponential need comes as we implement massive machine-type communications, where the machines, through their software, will talk to other machines. It is estimated that by 2025, there will be 100 billion such machines, or 12 times the human population. They will control critical infrastructure in healthcare, in energy management, in policing, and in transportation. And to do so, require higher communication speeds, higher bandwidth, and lower latency. And this is what 5G promises. Speed is the rate at which data can be downloaded. Although 5G will continue to leverage existing 4G low-band and mid-band radio networks for longer haul signals, the breakthrough for 5G is in utilizing a new higher frequency band, high band, or millimeter wave, for short-distance signals. The problem with high frequency is that the short wavelength signals have trouble going through or around obstacles. To ensure coverage, 5G will need to deploy up to 400 times more macro and small cell transmitters than are currently used in 4G. The new frequency band, along with more complex communication protocols, will increase average speed from 40 megabits per second to 600 megabits per second, or 15 times. This reduces the download speed of a television series from 70 seconds to 4 seconds. Bandwidth is the maximum amount of data that can be transmitted at the same time. The problem with today's 4G is that the low and mid bands are crowded, and there's no more spectrum available, which slows down traffic. The new millimeter wave has lots of room, and therefore the amount of traffic can be increased dramatically. Bandwidth increases from 200 megabits per second to 1 gigabit per second, or 5 times. This translates to the ability to service 1,000 times more users per given area. Latency is the time it takes for devices to communicate with each other. It is the inherent delay. 5G will employ localized edge servers to store information closer to the users. 5G small cells will also be able to track users and direct communications to them, more like a spotlight instead of the existing floodlight approach. These factors, along with changes in the information packets, means that latency within the 5G system will be reduced from 50 milliseconds to 1 millisecond, or 50 times. Put in context, the delay in humans between seeing an object and the brain receiving the image is 10 milliseconds. 5G will be 10 times faster than humans. 5G will continue to use a combination of through-air radio frequency signals, through fiber optic cable light signals, and through copper electrical signals to move data from source to user. More small cells, new base stations, additional edge servers, and thousands of new devices communicating within the 5G ecosystem. This means more networking components, more power magnetics, and more wireless antennas. So what can Pulse Electronics offer that goes inside 5G?
Hello, my name is Greg, and I am the Field Application Engineer for Pulse Electronics' Wireless Business Unit in the Americas. I will be presenting the antenna options for 5G FR1 that we have already designed in our manufacturing. We offer a very wide selection of antennas, from smaller embedded antennas that will be soldered directly to PCBs, to larger external antennas that will be for outdoor use, such as on a meter enclosure. We make wireless power charging coils and LDS antennas as well, and also in-building DAS antennas. For today, let's focus on our 5G selection. For a 5G embedded solution, I want to introduce our W3415. As embedded implies, it is an SMD and is fully SMT compatible. This antenna covers frequencies from 600 to 6000 MHz with good efficiency. This antenna does have requirements of the PCB it is mounted on in order to perform at its peak. While it is only 40 by 7 mm squared itself, it does require an additional 15 mm of ground clearance in front of the antenna, and it is recommended to have 120 mm of ground plane for the antenna in order to perform at its best. You can, of course, though, use this area for additional components such as the radio. It's not all lost to ground. This is an excellent solution for a more compact device such as a modem. Do please see the datasheet for full layout recommendations. Next up are antennas for products requiring an internal solution that isn't embedded. These flexible antennas can be folded around the contours of the plastic housing of a device so that they may be applicable even in devices too small for that recommended PCB length of the W3415. The W3554 performs well from 700 through 6000 MHz, while the W3929 performs well from 600 through 4000 MHz. The standard models of these antennas have a U.FL compatible connector, but of course we can produce these with various cable lengths and connectors as required. They feature mounting adhesive for easy manufacturing into the device, even on corners, and they work well for more compact devices and in the IoT world. Outside of device housing, we have our stick or blade style of external antennas. These swivel-mounted dipoles function strongly on their own, not requiring any ground plane assistance. The W5150 and W5151 both function very well from 600 to 6000 MHz. They are only 200 mm in length after the knuckle, which is a relatively short length for the high performance in this independent structure. They work well at all angles of operation for the blade relative to the connector that even includes resting straight. So these sleek antennas are perfect for gateways or other devices with an external connector that shouldn't have the antenna mounted directly onto the surface. For more rugged outdoor solutions, our low-profile transit antennas are high-performance monopoles for mounting onto a ground plane. They have very high efficiency, even though they are less than 100 mm in height and are only 41 mm at their widest. They cover frequencies from 600 all the way to 7125 MHz and perform well throughout. These compact antennas come in black and white, and the direct mount with nut option is excellent when a tamper-proof solution is required. These are perfect for installation on metal meter enclosures or junction boxes, or any other metal surface. An NMO version that will be more prepared to work with NMO mounts that are already installed on vehicles will soon be available as well. For a final independent dipole solution, I present the RO600/71NF kit. This 220mm long dipole has excellent performance from 600 through 7125 MHz with an omnidirectional pattern throughout. It is perfect for providing connectivity to an otherwise isolated device. It is also packaged with a bracket for easy mounting. Meanwhile, for a unique magnetic mount solution, our LPT600 antennas are perfect for mounting onto a vehicle or other surface where a hole for the mount isn't an option. These 100mm tall monopoles also have excellent radiation characteristics with high efficiency, even with 10 feet of built-in cable. Finally, I present our Twin Castle 9-in-1 design. This direct mount solution has 4 FR1 antennas covering 617 to 7125 MHz, 4 Wi-Fi antennas covering the 2.4 GHz band and 4900 to 7125 MHz, as well as 1 active GNSS element, which can cover either the L1 and L2 frequencies or the L1 and L5 frequencies as desired. Both the 5G and the Wi-Fi antennas perform well and have high isolation between the elements. It is designed for vehicle installation, but will work on other metal ground planes too. It will be an excellent option for other machine-to-machine use. While all of the solutions shown were catalog options, we do have the capability to provide custom designs and solutions as well. Along with custom antennas of the mechanical styles shown already, Pulse Electronics has a long history with LDS antennas, both in design and manufacture. We have the know-how to design 5G LDS solutions, such as for cell phones and laptops, and can build the antenna from the plastic up. If you have an antenna requirement, we have a solution. Pulse Electronics inside 5G.
My name is John Gallagher, and I am the Global Marketing Manager for the Power Product Business Unit at Pulse Electronics. I will be reviewing our power magnetic options for 5G. All of the things of 5G need power, which means they need a power supply to convert the available and often wide-ranging input voltage to a tightly controlled and regulated output voltage and current. A critical part of these power supplies is the power magnetics, which include power inductors, power transformers, isolation transformers, current sense magnetics, and common mode chokes. Increasingly, in order to reduce cost and increase flexibility, customers design their own power supplies and incorporate them onto the main printed circuit board of their products. This means in every product, From the infrastructure side of servers, edge computing, base stations, small cells, routers, switches, and gateways, to the user side of cell phones, tablets, laptops, security cameras, medical equipment, industrial IoT, and EVs, there are power magnetic requirements. Power inductors are used in non-isolated circuits to convert voltages, and in isolated and non-isolated circuits to smooth out currents and reduce EMI. Pulse designs and manufactures multiple inductor constructions: power beads, drum cores, round wire coils, toroids, molded powder, and composite. Power beads are commonly used in 5G servers and edge servers in high current multi-phase applications. They are used to power processors, memory modules, and high current ASICs and FPGAs. They have extremely high currents, greater than 100 amps, and very low resistance, less than 200 microohms. Molded and composite inductors are used throughout the 5G system, in both user-side devices and within the 5G infrastructure, suitable for mid-range power needs and height-constrained applications. The magnetic core allows for soft saturation. Round wire coil inductors are primarily used on the infrastructure side of 5G, in base stations and servers. They are designed to minimize board space, and the ferrite core construction maximizes circuit efficiency. Power transformers are used in isolated power supplies to convert voltages and create an electrical and safety barrier between the input and output. Power transformers are used throughout the 5G ecosystem. Pulse designs and manufactures multiple through-hole, surface mount, and planar constructions for a wide variety of switching topologies. Our catalog and custom solutions are designed using advanced 2D and 3D finite element analysis to optimize geometries and maximize efficiency. Our latest catalog designs enable us to double the power density when compared to industry-standard solutions. Common mode chokes are used to reduce electromagnetic interference within the power supplies used in 5G. This is critical to ensure that noise does not couple to the communication channels. Pulse manufactures a wide range of surface mount and through-hole common mode chokes, with catalog parts exceeding 40 amps and custom solutions exceeding 100 amps. Our latest catalog offerings enable high current and impedance in surface mount platforms. Isolation transformers are used to drive IGBTs, FETs, and other switches while maintaining isolation between input and output. These transformers come in a wide range of packages, depending on the isolation voltages and safety agency certifications that are required. Pulse offers parts from 1500 volt isolation up to 5000 volts with functional, basic, and reinforced insulation. Current sense magnetics are used as an extremely low-loss method for sensing currents within a circuit. This is required in many applications for circuit control and also for safety isolation. Like isolation transformers, Pulse offers parts from 1500 volt isolation up to 5000 volts with functional, basic, and reinforced insulation. Our latest catalog offerings enable 30 amp capability and up to 4400 volt isolation within a surface mount platform. Whether the application requires milliwatts or kilowatts, on the infrastructure or device side, Pulse Electronics has a power magnetic solution. Power is everywhere, inside 5G.
Hi, my name is Scott Johnson. I am the Senior Marketing Specialist for the Network Business Unit at Pulse Electronics. I will be reviewing our network solutions for 5G. Although the major changes in the 5G mobile network are occurring in the through-air element of communications, a significant and growing portion of the network will be cabled through either optical fiber or copper. The Networking Division's portfolio covers both optical and wired solutions within the 5G ecosystem and includes Ethernet magnetics, Ethernet connector modules, telecom solutions, and connectors. This roadmap highlights some of the future developments that the leading 5G infrastructure equipment makers are requesting. The trend is faster data rates and higher bandwidths to support higher remote powering over long distances, as well as ensuring that the designs are manufacturable and affordable. High-power PoE++ discrete solutions are favored by designers where space is not at a premium or if there is a proprietary connection system different from the standard RJ45. Although there are cost advantages, it is more technically complex to lay out a discrete solution. For indoor uses, the compact H7229 FNL or larger H7232 FNL are recommended. For outdoor uses, the HX7260NL supports PoE up to 100 watts in the same package as the H7232 FNL, making upgrades from indoor units to outdoor units a straightforward component swap. High power PoE++ alternatives. In applications where performance and functionality can be traded for cost, the 2.5 gig and 5 gig products can be used as drop-in alternatives to the 10 gig products mentioned previously. For 2.5 gig, the HU4006NL can replace the 10 gig H7229 FNL. For 5 gig, the H5G1002NL and the HX5G1001NL can replace the H7223 FNL and H7800NL respectively. The HU4108NL and HUA4103NL are compact and slimline packages. As the PCB layout for these higher data rate discrete solutions can be problematic and requires skilled trace routing and impedance matching, many engineers opt for the drop-in solution of an integrated module, ICM. Pulse offers 3 plug-in orientations for single-port RJ45 devices with power handling capability. These ICMs are used on small cells, mass mount hubs, servers, and edge servers. The JK0, JXK0, or JT7 product ranges are right-angled entry and common in the market. The J1V is a top entry design ideal for ceiling-mounted devices where cabling is not to be seen. The J2V design is an angled entry for wall and mast mount, offering easy access to disconnect and move the antenna units. The JX1W platform is a dual-port ICM with an 18-degree inclined connector suitable for 1 gig to 10 gig and can support up to 120 watts for both indoor and outdoor applications where daisy-chained units are used, saving cabling costs. 4-port integrated ICM modules can provide 140 watts of DC power and are often used in single height. 1U pizza box style switches, hubs, routers, or mini base stations where 4 antennas are connected and remotely powered up a mast. The JX1N has the locking latch tab with LEDs. The JX0N has the tab on the bottom. The JXT6-14XXNL is a press fit option for silicon intense real estate where a secondary reflow or wave soldering process might damage the silicon. For large switches, hubs, routers, and dedicated base stations where multiple antennas or wired access points are connected and remotely powered, the 2x-N connectors are ideal solutions. The PressFit JXT5 family covers 2x1 to 2x8 and has 2 options, metal fingers or elastomer gasket to reduce EMI. They are fitted with light pipes rather than LEDs, and wave soldering options are available. To go faster and further, we need to enter the optical realm, and here Pulse has a vast array of SFP and SFP Plus cages and connectors, single port 1x1, multi-port 1x-N, and multi-port 2x-NL. The next generation from Pulse is the SFP28. 1x6 port press fit SFPP-1601-L, capable of supporting the SFP MSA transceivers operating at 25 to approximately 28 gigabits per second for backhaul applications within the 5G infrastructure. The SFP28 1x6 port press fit has superior EMI shielding effectiveness and high reliability for outdoor use. Pulse also has a wide range of EMI and RFI products for 5G applications, including EMC suppression beads and chokes from 0402 to 1812 sizes, and 2-wire chip chokes in 0805 to 1812 sizes, high frequency balance for amplifier matching and single to double init conversion, and RF inductors in both wire-wound ferrite and ceramic body, and multi-layer technology in 0402 to 1008 sizes.
The 5G market will expand exponentially for both supply-side infrastructure and demand-side devices. If you have a requirement for network, wireless, or power components, we have a solution. Pulse Electronics, inside 5G. Thank you for listening.